All right, so in the previous video, we went through and find the eigenvalue or eigenvector corresponding to -1. So now let's go through and find the eigenvectors corresponding to -2 and for -3. And just like before, we're going to go in and we're going to subtract -2 off of the main diagonal. So that's going to change the -6 to a +4, or sorry, to a -4. And then our lower entry down here will be -1 plus 2, so that's going to be just a 1. And then down here, that's a +1 minus a -2, that's going to become a 3. And again, the other entries are going to stay exactly the same. And once again, we'll go to our graphing calculator and put this into row reduced echelon form. All right, so we've got a -4. The other numbers are the same. Then we've got a 1. Other numbers are the same. And then finally a 3 at the end. You can quit out of there, do the row reduced echelon form again, and convert this into fractions. So we've got a 1, 0, 1/2, a 0, a 1, and a -1/2. And again, that very important row of zeros. Again, that's times some unknown v1, v2, v3, giving us the 0 vector. All right, so now we go through and start multiplying this out. The top row says that 1 v1 plus 0 v2 plus 1/2 of v3 equals 0. So that tells us that v1 is just equal to -1/2 of v3. The second row tells us that 1 of the v2s minus 1/2 of the v3s is equal to 0. So that tells us that v2 is equal to 1/2 of v3. So they're almost the same, except one is an opposite. So again, v2 is 1/2 of v3. So we put this together in vector form. We're going to have a -1/2 v3, 1/2 v3, and a v3. But again, we really don't want to keep this -1/2, 1/2, and 1 as our vector. So we're going to multiply the whole vector by 2. So we've got a -1, a 1, and a 2 being our eigenvector for lambda2 equals -2. We'll now go through and do the same thing for lambda equals -3. Again, that has us going back to matrix A and subtracting a -3 off the main diagonal. So that first entry is now going to be a -3. The middle entry is going to be a 2. And the last entry is going to be a 4 down here. And the other entries are still all the same. Once again, we'll do our row reduced echelon form from our graphing calculator. And that row reduced echelon form in fraction form is 0, 1, 1/2, 0, 1, -1/2. And that can't be right. That would be the same exact thing. All right, so that matrix right there is actually the previous matrix, because when I went into my calculator, I didn't hit RREF again, I just hit fraction again. So let's actually erase that matrix there. And the correct matrix from our calculator is actually going to be 1, 0, 1, and then 0, 1, 0, 0, 0, 0. And the red flag there in that problem was the fact that you can't have the same exact vector for two different eigenvalues, because vectors have to be linearly independent, and obviously they're not independent if they are exactly the same thing. So again, that is the correct RREF right there. Again, this is times a v1, v2, v3, equaling 0, 0, 0. And when we start multiplying this out, we will notice that we get a 1v1 plus 1v3 equals 0, saying that v1 is the opposite of v3. And then you'll notice that you get just plain 1v2 equals 0. That forces the v2 to be equal to 0. So therefore your matrix or your vector is going to be negative v3, 0, v3, which simplifies into just negative 1, 0, 1 for that corresponding eigenvector. And again, that's for lambda is equal to negative 3. So now we have our 3 eigenvalues and our 3 eigenvectors. Well, now for the next video, put everything together to get our solution.